Welcome back to our Network Architecture Design series. I'm Ray. This is Season 2, The Art of Tradeoffs. Episode 6, Understanding Business Needs. It must be pointed out that network architecture design does not begin with a technology or a diagram. It begins with understanding business needs. Let's start. In the real world, business inputs may come from many sources, such as meetings, conversations, emails, and documents. Business inputs are the raw material we gather along the way. Business inputs rarely arrive in a neat requirements document. Instead, they appear in many different forms, such as company background, existing environment and current states, the business goals, objectives, problems, requirements, and constraints. As architects, our job is not simply to read these inputs. Our job is to analyze them. To make that analysis easier, we simplify the many different forms of business inputs into 3 categories: requirements, constraints, information or noise. Requirements tell us what the design must achieve or solve. Constraints define the limitation or boundary that the design must respect. Information provides useful context but doesn't directly influence the design. The combination of requirements and constraints reveals the true business needs. Business needs are what the business is ultimately trying to achieve or fix. For example, improve availability, improve user experience, increase reliability, support growth, simplify operations, strengthen security, reduce cost. Business needs weren't written anywhere. They were derived through the analysis of business inputs. Architecture design begins by gathering business inputs from meetings, emails, interviews, and existing documentation. Through business analysis, we identify the underlying business needs and translate them into architecture design drivers. These design drivers become the foundation for evaluating architecture options, making informed trade-offs, and ultimately arriving at the final design. Here we see the 7 major architecture design drivers. In the next episode, we'll introduce the 7 universal architecture design drivers and explain why they provide a complete framework for guiding architecture design. In this episode, our focus is on understanding business needs. Before we dive into the business needs analysis, let's step back and look at the overall architecture design process. Every architecture project begins with business inputs. Through business needs analysis, we identify the underlying business needs. Those business needs are then translated into architecture design drivers. The design drivers become the foundation for evaluating architecture options, making trade-offs, and ultimately arriving at the final design. Today, our focus is this step: business needs analysis. So, how do we get from business inputs to business needs? We follow a simple 6-step workflow to perform business needs analysis. Here's the workflow we'll use every time. Read. It means read through the business scenario or document. Highlight. It means highlight the sentence or phrase if that matters. Understand. To understand the highlighted items, we can ask ourselves 2 questions. Is it a requirement, a constraint, or context information? And which of the design drivers does it relate to? Extract. To extract the info, we can use shorthand, short tags, short words, so fast to write, fast to scan later. Update. To add what you've learned to our working diagram and/or our analysis table. And finally, prioritize. Not every business need or design driver carries equal weight. Some are critical, some are mandatory, some are desirable, and some simply don't have enough information yet to determine their priority. Here is a typical, traditional enterprise network diagram. We can use it to document what we learned from business inputs. Why do we use a typical traditional enterprise network diagram? It is primarily for the sake of organizing, updating, and understanding information. For instance, regarding sections that haven't been updated, we can reasonably assume they follow the typical traditional enterprise network model. This allows us to quickly map out a client's network without needing to do extra work. This is a table used to document business needs and map them to design drivers. As you can see, here in the column Design Drivers, there are 7 major design drivers by the 7 rows. We'll cover these 7 major design drivers properly in next episode. For now, we just know this. Any business needs, which we identify from business inputs, including business goals, problems, requirements, constraints, are mapped to one of these 7 major design drivers. Every network design is ultimately organized around these 7 things. That's exactly why we sort everything into them. Next, let us work through a realistic business scenario to practice the business needs analysis workflow. Here's our scenario. 6 exhibits. Scenario title: Meridian Health Partners. Exhibit 1, Company Background. Exhibit 2, Current State, Summary. Exhibit 3, Email, Chief Operating Officer. Exhibit 4, Email, Chief Financial Officer. Exhibit 5, Email, Compliance and Security Officer. Exhibit 6, Interview Notes, IT Manager. Now, let's read. Exhibit 1, Company Background. Let's read it and pull out what matters. Meridian Health Partners operates 14 outpatient clinics across 3 states, with a primary data center in Columbus, Ohio, and a DR site in Indianapolis, Indiana. Let's highlight it. 14 outpatient clinics across 3 states. Primary data center in Columbus, DR site in Indianapolis. Let us understand these highlighted items. We should ask ourselves 2 questions here. First, is this a requirement, a constraint, or noise? Clearly, this is neither a requirement nor a constraint, but rather noise or information only. Second question, which of the 7 design drivers does it belong to? Noise, or information only, don't need to be mapped to a specific design driver, at least not yet. So, what is the next step? The next step is to extract information, then update our default diagram and/or table. Let's do it. 14 clinics. Here, the branch office is now clinic. 2 data centers, one at OH, one at IN. Let's continue to read. MHP employs approximately 900 staff and has grown primarily through acquisition. 2 clinics acquired this fiscal year, 3 more in due diligence for next year. Let's highlight it. Grown primarily through acquisition. 2 clinics acquired this fiscal year, 3 more in due diligence. Let us understand these highlighted items. Is this a requirement, a constraint, or noise? Clearly, this is a requirement because it is something we need to complete. Which of the 7 major design drivers should it map to? It should be mapped to Scalability, Adaptability, and Agility because it's regarding business growth. The next step is to extract information and update our working diagram. Let's do it. Here, SAA stands for Scalability, Adaptability, and Agility. R stands for Requirement. 2 clinic this year, 3 clinic in Dillage. Let's continue to read and highlight. MHP's IT organization is a 3-person network and infrastructure team reporting to the COO. Let us understand these highlighted items. For now, this is information only, or noise, so it's not mapped to any design drivers. Let's extract information and update our diagram. Three-person IT. Let's continue to read and highlight. MHP is subject to HIPAA due to its handling of protected health information. Clearly, this is constraint, and it's related to the design driver of security. Let's extract the information and update our diagram. SEC, C, HIPAA. Here, SEC represents the design driver of security, C represents constraints, and HIPAA is the security compliance standard that the network must adhere to. Now, let's read. Exhibit 2. Current state. Summary. 2 unplanned system-wide EHR outages this fiscal year, each exceeding 1 hour. Recovery to the DR site is manual. This is a requirement because it is a problem we should solve. This problem relates to the design driver of availability and resilience, as this design driver addresses service failures. Let's extract information and update our diagram. Here we use A and R to represent availability and resilience, and use R to represent requirement. 2 outage, 1 hour plus, disaster recovery by manual. Let us continue to read and highlight. A recent security audit found flat network segmentation between clinical, administrative, and guest traffic, a material finding. This sentence mentions flat network segmentation. From network security perspective, this is an issue we should address. In other words, this is a business requirement and related to the design driver of security. Let's extract the information and update our diagram. SEC, R, flat seg, audit finding. Let us continue to read. The 2 most recently acquired clinics remain on a separate legacy MPLS contract, with 18 months left on its term. The MPLS contract with 18 months left is a constraint that we need to take into account when we work for business growth. So this constraint is related to the design driver of scalability, adaptability, and agility. Let's extract information and update our diagram. SAA, C, legacy MPLS contract, 18 months left. Let us continue to read. IT operates reactively. Changes are manual. There is no centralized monitoring, and outages are often first reported by clinic staff rather than IT's own tools. This sentence describes the problems we face regarding network operations. So, this is a requirement related to operability, management, and observability. Let's extract information and update our diagram. OMOR, manual change, no monitor. Now, let's continue to read. Exhibit 3, email, Chief Operating Officer. Clinical staff have raised concerns about EHR responsiveness during peak hours, which clinic managers connect to reduced patient intake. These sentences describe a performance issue that needs to be addressed. Therefore, this is a requirement and related to design driver of performance. Let us extract the info and upgrade the diagram. PERF, R, EHR slow, peak hours, down intake. Let's continue to read. We've had 2 unplanned outages this year, each over an hour, system-wide. The board considers this risk unacceptable, given our compliance obligations and patient care responsibilities. Please note that we are already aware of this issue and have already updated our diagram accordingly. This issue is mentioned here again in an email from the Chief Operating Officer, COO, and explicitly deemed unacceptable, citing reasons such as compliance obligations and patient care responsibilities. What does this mean? It means the board has stepped in. This indicates that the priority level should be raised to the highest status, such as critical. Now, let us extract the info and upgrade the diagram. Board equals risk unacceptable. Up priority. Let's continue to read. Our IT team spends most of its time reacting rather than improving, and we often hear about problems from clinic staff before our own tools tell us anything. Please note again, we are already aware of this issue and have already updated our diagram accordingly. This issue is mentioned again by COO email. This means that this is an issue that must be handled appropriately. The priority level should be raised. Let us extract the info and upgrade the diagram. OMOR, reactive, not proactive, up priority. Let's continue to read. Given our acquisition pace, any proposed design needs to bring a new clinic online in weeks, not months. Don't design around today's footprint as if it's permanent. Here, bring a new clinic online in weeks, not months. This is the requirement regarding the speed of implementation. It is related to the design driver of agility. Let us now consider this statement. Don't design around today's footprint as if it's permanent. What does this mean? It means the network must be designed to adapt to future changes. It is a requirement regarding adaptability. Among the 7 major design drivers, we categorize all these types of requirements under SAA, Scalability, Adaptability, and Agility. Let us extract the info and update diagram, SAA, R, new CLIN equals WKS, not MO. Let's continue to read. Every capital request over $50,000 goes through our finance committee, and they evaluate total cost of ownership, not just install cost. My understanding, this is constraint and map it to cost, so we can extract and update cost, C, greater than $50,000 to finance, TCO focus. Let's continue to read. A phased, multi-year approach is acceptable. One large upfront ask is not. This is constraint. Map it to cost. Let us extract and update. Cost, C. Phased. Okay, no big upfront. Now, let us read. Exhibit 4. Email, Chief Financial Officer. This is CFO email. Let us watch closely. This is where the story stops being one voice. Let us read. I don't dispute the outage risk Sandra described, and I'll support capital to resolve that specifically. Please note that the outages here has already been mentioned and updated. What's new here is that this business requirement is funded. Let us extract and update. Funded. Let us continue to read. I'm not comfortable approving an early exit from our legacy MPLS contract at the 2 acquired clinics. The termination penalty is material, with 18 months left on the term. This is constraint. This constraint has already been mentioned and updated. Here, it is emphasized that early exit is not permitted and that the termination penalty will be imposed. Let us extract and update. No early exit. Penalty. Let us continue to read. I'd also push back gently on urgency for the segmentation remediation. Compliance has told us we have 12 months before it becomes a formal corrective action item. Here, the segmentation remediation has already been mentioned and updated. The new is that it was asked to slow down. This is constraint. It's related to security. Let us extract and update. Sec C slow pace pref 12-month window. Now, let us read Exhibit 5, Email, Compliance and Security Officer. This email from Priya, a Compliance and Security Officer. Let's start. My expectation is full isolation between clinical, administrative, and guest traffic with policy enforcement between them, not just better VLAN hygiene. Please note that this is the same segmentation requirement that is already mentioned in earlier Marcus email. Same requirement and related to the same design driver, security. But Marcus wants this slower and cheaper. Here, Priya wants it to go further than a basic fix. Notice the conflict, two different expectations. Let's extract and update sec R full isolation policy inform. Let's continue to read. I need whatever is proposed to hold up against a follow-up audit. My understanding is this is a constraint instead of requirement. Whatever is proposed, it means the architecture design should adhere to HIPAA standard discussed earlier in Exhibit 1, so as to it can hold up against a follow-up audit. Obliviously, this is actually confirmed the constraint that is already mentioned in Exhibit 1. Let's extract and update. Sec C confirmed. Now, let us start. Exhibit 6, Interview Notes, IT Manager. This is last exhibit, Devon's notes, and this is where a second conflict shows up. Let us read. We can't take a clinic offline during business hours for any reason. Maintenance windows are after hours, 2 hours max. This is constraint related to operability, management, and observability. Let's extract and update. OMOC. No bus hour outage, 2-hour window. Let us continue to read. The two acquired clinics are locked into their MPLS contract for 18 more months. Early exit isn't something finance will approve. It is worth noting that this is a constraint that we have already known, and it's related to scalability, adaptability, and agility. It's the same fact, but independently verified by a second stakeholder. Therefore, we can extract and update it to double confirmed. Let us continue to read. This year's capital budget is already capped. This is a constraint to cost. It's the same fact we already know, but conformed here. Let's extract and update. Confirmed. Let us continue to read. Priya wants full per-clinic isolation. I understand why, but I want to be honest. If that means managing a pile of VRFs and ACLs by hand across 14, then 20, then 30 sites, we will not keep up. Whatever we do has to be something 3 people can actually operate. Let us understand the meaning of this sentence. This sentence means that the scale manual ops is unable to perform. Clearly, this is an operational constraint. It directly limits the space of the security solution. To extract, it would be OMOC can't scale manual ops, bound to security. Here's everything we pulled out of 6 documents, organized by design driver. Please notice that the priorities are being classified into 4 tiers: P1, critical, P2, mandatory, P3, desirable, and P4, best effort, or called unranked. The tier logic as follows. P1, critical. For example, attracting board attention, having an approved budget, or facing security/legal risks if currently ignored. P2, mandatory. It signifies a task that requires must be addressed, involving compliance, repeated stakeholder confirmation, or a clear business deadline, but allows for a relatively generous timeframe. P3, desirable. The task holds value, such as supporting broader strategies, but carries no mandatory requirements, no deadlines, no committed funding, and no compliance obligations. P4, best effort. No input has surfaced yet. It's worth noting, this prioritization becomes extremely useful later when we start making trade-offs and design decisions. We'll come back to prioritization again in later episodes. In this episode, we learned that every architecture design starts by gathering business inputs. Through business analysis, we identify the underlying business needs and map business needs into architecture design drivers. Whenever you analyze a business scenario, remember these 6 steps: read, highlight, understand, extract, update, prioritize. Whether you're working with a client or taking the CCDE exam, this workflow helps you organize information, identify what's important, and build a solid foundation before making any design decisions. In the next episode, we'll introduce the 7 universal architecture design drivers. These design drivers are not only the driving forces behind network architecture design, but also the common objectives of network design and the universal standards for evaluating the quality of network design. If you have any questions about this case study, please leave them in the comments below. And if you found this video helpful, don't forget to like, subscribe, and follow the series. Thank you for watching. I'm Ray, and I'll see you in the next video.